What is deep learning? Deep learning is a subset of machine learning, which itself is a subset of artificial intelligence, or AI. Deep learning specifically deals with algorithms inspired by the structure and function of the brain, called artificial neural networks. These neural networks are designed to automatically learn and improve from experience without being explicitly programmed to do so. Key characteristics of deep learning. First, artificial neural networks. Deep learning uses multi-layered neural networks, also known as deep neural networks. These networks consist of layers of nodes or neurons, each connected to neurons in the previous and next layers. Second, learning from data. Deep learning models learn from large amounts of data. They can automatically extract features from raw data, eliminating the need for manual feature engineering. Third, hierarchical feature learning. These models learn hierarchical representations of data. For example, in image recognition, lower layers might identify edges and textures, while higher layers might recognize more complex patterns such as objects or faces. And finally, end-to-end training. Deep learning models are trained end-to-end, meaning they learn to map inputs directly to outputs through multiple layers of transformations. How deep learning works. The working of deep learning can be summarized in the following steps. First, data input. The model takes in a large amount of raw data, such as images, text, or audio. Second, neural network structure. The data passes through multiple layers of neurons. Each layer performs a set of operations on the input data, such as matrix multiplications and nonlinear transformations. Third, forward propagation. Data is passed through the network layer by layer. Each neuron processes the input it receives from the previous layer, applies an activation function, and passes the result to the next layer. Fourth, loss calculation. At the output layer, the model's predictions are compared to the actual values using a loss function, which measures the error in predictions. Fifth, backward propagation. The error is propagated back through the network, and the model's parameters, weights, and biases are adjusted to minimize the loss. This process is known as backpropagation. Sixth, optimization. An optimization algorithm, such as stochastic gradient descent or SGD, is used to update the model's parameters iteratively to minimize the loss function. And finally, training. The model undergoes multiple iterations or epochs of forward and backward propagation until the loss stabilizes or reaches an acceptable level. Common architectures in deep learning. 1. Convolutional neural networks, or CNNs, are primarily used for image data. CNNs are designed to automatically and adaptively learn spatial hierarchies of features. They use convolutional layers to scan over input data and capture spatial relationships. 2. Recurrent neural networks, or RNNs, are suitable for sequential data like time series or natural language. RNNs have connections that form directed cycles, allowing them to maintain a memory of previous inputs. 3. Long short-term memory networks, or LSTMs, are a type of RNN that is particularly good at learning long-term dependencies. LSTMs can remember information for long periods, which helps in tasks like language modeling and translation. 4. Generative adversarial networks, or GANs, consist of two networks, a generator and a discriminator, that compete against each other. GANs are used for generating realistic data, such as images from random noise. 5. Transformers are used primarily in natural language processing, or NLP. Transformers can handle long-range dependencies using self-attention mechanisms, leading to significant improvements in tasks like translation and text generation. Applications of deep learning. Deep learning has a wide range of applications across various fields. 1. In computer vision, it is used for image recognition, object detection, facial recognition, and image generation. 2. In natural language processing, or NLP, it aids in language translation, sentiment analysis, text generation, and speech recognition. 3. In healthcare, deep learning assists with disease diagnosis, medical image analysis, drug discovery, and personalized medicine. 4. In autonomous systems, it powers self-driving cars, drones, and robotics. 5. In finance, it is used for fraud detection, algorithmic trading, and risk assessment. 6. In entertainment, deep learning enhances content recommendation systems, video and music generation, and game playing. Conclusion. Deep learning is a powerful and rapidly evolving field within AI, leveraging the capabilities of neural networks to learn from vast amounts of data and perform complex tasks. Its ability to automatically extract features and learn hierarchical representations makes it highly effective for a wide range of applications. from image and speech recognition to autonomous driving and natural language processing. For more explanations of AI terminology, hop over to Ai-Epicentre.com.